In this video, we're going to have a look at expanding brackets with indices. This is now going to bring together all of our ideas that were encountered so far. Okay, so we want to simplify the following. 2x cubed multiplied by x to the 6 subtract 3x. I'm going to take a long approach to this. You can probably skip this line that I'm about to do. I'm just going to write this out. I actually like to write this out. I think it makes things a bit clearer. That's going to be times x to the power 6 subtract 2x cubed times 3x. I like to write this step out. Pupils can often just do this in their head, but sometimes it's just nice. It makes things a wee bit clearer for me at least, and makes me make sure that I'm not making any mistakes and taking any shortcuts I shouldn't be taking. Right, let's have a look at what we've got. Well, we've got a power multiplied by a power and the bases are the same. Or sorry, I'm multiplying indices and the bases are the same, so I can add the powers. That's going to become 2x to the power 9. And then here, I've got the same bases once again. I'm multiplying, so I can add the powers. This is going to become 6x to the power 4. There's like a wee hidden power 1 there. So that's my final answer. I can't simplify this any further. Okay, we could not simplify, like some people might say, oh, that's going to be negative 4x to the 5. But that wouldn't work. It would, because the powers are the same, just like when you're collecting like terms, if you had 2x cubed plus 3x squared plus x squared, you could only combine your x squared. So here we've got different powers, so we can't combine them. So that was example 1. Okay, example 2. Made it a little bit harder this time. First thing you should hopefully spot in example 2 is that we've got a fraction involved and one of our algebraic terms is on the denominator. So that's problematic. So what we're going to have to do first here is we're going to need to rewrite this problem in such a way that this is not on the denominator. And we can do that by taking it to the numerator as such. Remember, we've got this rule, or this fact that we can use. If we've got x to the negative 3, that's the same as 1 over x cubed. So here we're wanting to kind of work backwards. So we've got 2 over x squared. Well, that's the same as 2x to the negative 2. Okay, so if ever we've got any fractions, we need to get those written as negative powers first. Okay, let's multiply out these brackets. I'm going to take the long approach here. So I've got 5x squared multiplied by x to the half plus, what's that? 5x squared times 2x to the negative 2. Okay, I can see I'm multiplying here, so I'm going to add the powers. So I'm going to have 5x to the power. I've got 2 plus a half. 2 plus a half is 2.5. 2.5 is 5 over 2. So that's 5x to the power 5 over 2 plus, I'm going to multiply these guys, that's going to be 10x to the power. So I'm multiplying, so I'm going to add the powers. 2 plus minus 2. 2, right that side, 2 plus minus 2, well that's 0. Okay, so then this is now a wee fact that you should be able to recall. Anything to the power 0 is 1. So hopefully you can see that x is being raised to that power 0 there. So I can rewrite this as 5x to the power 5 over 2 plus 10 lots of 1. And that's going to be 5x to the 5 over 2 plus 10. And if you want, we could rewrite this and put the roots back in. So that would become 5 times the square root of x to the power 5 plus 10. Once again, one wee thing to note here, this does not equal 15x to the 5 over 2. To get 15x to the 5 over 2, we would have to have had this here. 5 lots of 5 over 2 plus 10 lots of 5 over 2, and we don't have that in this case. We went from here to here by recalling one of our index laws, that when we've got m, or a to the m over n, that's the same as the nth root of a to the m. And from here to here, we recall that anything to the power 0 is 1. Okay, so this is us now starting to get in towards the territory of higher. This is a skill that is like part of preparing to do a problem at higher. You'll need to be able to prepare to do this at higher maths. Okay, we've got one final problem. Okay, so a few things to consider here. Notice that although I've got x's, we don't have any powers. The first thing we're going to have to do is we're going to need to rewrite these with powers. So here I've got the square root of x, so we need to remember that the square root is the same as the power of half. And similarly, I've got the cubed root of x, that's the same as x to the power a third, minus 3. Okay, I've got an x on the denominator, I want to take that to the numerator, so I'm not multiplying anything out yet. That's going to be 2x to the negative a third. Subtract 3. Now we can multiply. X to the half times 2x to the minus a third. Subtract x to the half multiplied by 3. Okay, let's have a look at this problem. We're multiplying, so we can add the powers. We're going to get 2x to the power. Let's work this out to the side. We've got a half plus minus a third. So when we're adding a negative, that's the same as subtracting. So we're going to do a half minus a third. That's the same as 3/6 subtract 2/6, which is 1/6. So this is going to become 2x to the 1/6 subtract 3x to the half. And if we want to, we can put our roots back in. That's going to be 2 times the 6th root of x subtract 3 times the square root of x. When it's a square root, we don't usually write that 2. Okay, so certainly these questions are now at A level for National 5. Hopefully that was helpful. Thank you very much.